Hello, my name's Simon Redford. I'm doing a sequence of YouTube videos to describe how I put together the simulation of a scroll expander. A scroll expander is two scrolls or spirals interleaved with one another. So there's one, there's two, and displaced and orbiting one against the other to trap pockets of gas which expand outwards, and in doing so turn one of the scrolls to create power. I'll just show you that running. There's a pocket of gas to show it going outwards. There's the orbit to show you it's quite small. That gets to the end, pops out, and another cycle starts. How a scroll works and what it's for is not really the subject of this video. I will say more about that if people are interested. What I can tell you is that the opposite of a scroll expander, a scroll compressor, are found in their millions in cars all over the world for air conditioning. So these are quite common machines, but you've probably never seen this rather lovely motion that takes place inside them. So let's get rid of that. Before moving to how I created this simulation, I wanted to go through the components that you need to understand to create this type of graphical simulation. And I'm doing this in the Netbeans and Java application environment. So I'm using, just to be clear, Java version 8 from Oracle, update 181 apparently. It's free at the moment, but won't be forever, is my understanding. And Netbeans, which is free, I'm using IDE 8.2. You only need to download the Java SE part of this. My intention is not to describe anything more about the environment or how to load it, because there's plenty of videos on YouTube about this. In order to show you how we put together, let me just get rid of that, how we put together these simulations, I created a sequence. The first one was stopwatch. So this is a really simple application to show you how you handle time, which you require, of course, to be able to update each frame of the simulation. So this is stopwatch. We can run it. It counts up in hundredths of seconds. We can stop it, run it, stop it, reset it, run it, etc. Very simple application that introduces you to a lot of the concepts of working in this environment and how to handle time, how to stop and start time. So it's critical to have that to be able to do this type of simulation. Okay, I then moved on in the last video to look at Animate, the commonly named application, which took us from drawing a very simple and rather gruesome looking animation of a girl with a red dress on to how we could eventually get to very smooth and slightly better looking graphics, slightly happy looking girl, looking like she's waving at us in a continuous motion. So there's lots of principles here about how we get smooth graphics, how we make certain that those update in the background and then get transferred to the screen so you don't get awful flashing of the screen, etc. So both of those you can see prior to this one, you should see prior to this one. This third video covers just one extra component before we finally get to see the scrolling operation. And so I created one here to show you a clock, and I'll explain why. Let me take myself off the screen first, and we'll move into that particular package. Okay, let's just bring that back up for a moment. What we have here, obviously every second at the moment, we are updating the position of a second hand, a minute hand, an hour hand. And if you notice, is that they are actually moving on every clock tick, or every time there's a pixel's worth to move across. However, a lot of information on this screen, all of this outer clock face, its numbers, and all of these tick marks, each of which has to be worked at a particular angle, don't change from time to time. So we can actually draw this lot separately as a background and then place on the second, minute and hour hands as we require them, and the date which we update, because obviously if it goes over midnight we have to update that. So let me take you through what's actually in this application. So it's the usual design, very similar to the others. We have a design phase, and here all we have is a J-frame, graphical user interface, and on that we have a panel, a J panel, which we've renamed clock panel. This is a particular size, 600 by 600. We wanted it to be square for good reasons. I wanted it to be black to show up the best colour. We have no buttons on this application. The only effective button is the cross at the top of the close window cross on the window when it runs. So this has got to run straight from the beginning. We've got no buttons to start it. So the first thing that's different to any of the previous ones is I have used, find it, frustrating, I need to find it, window activated handler. So this is from the J-frame itself. We have properties, code, etc., like any other object. There's very few properties actually, but the events here allows us to set up an event for when this window is activated. So window activated, call this routine called window activated handler. And that's exactly what I've done. So window activated handler is a good way of saying once this is ready to run, then set up the whatever else you want it to do. We can't do that from the main event because the main event, the entrance to the entry point to the Java program, hasn't yet invoked the graphical user interface. So if we put it in here, it would fail. You could, I'm told, put it in this one, which is where you init components. But I like to do it very explicitly. I say the window's open, now we set up what we want to do. So in here, we're doing exactly the same things we did for the stopwatch and also for the animated version of Annie, which is set up a timer and a timer task. So the timer is called clock timer. The timer task is clock task, and both of these, of course, require the timer and timer task libraries. Every time a timer task is called, we run a routine called update time, which is going to draw the hands. Before we start running, and once only, we call draw clock face. So this puts together the background. Then, if you recall how we put together timers, the last part of this is we set the clock timer to tick at a particular tick rate. Here it's 1000 milliseconds, it's every second. We'll change that later on, so it can go a lot faster. And every second it then calls clock task, which is here, and here, and then that calls update time. So every second update time gets called. So before we get to update time, let's first look at a global set of variables here. We've seen this before, where in order to get nice smooth images on screen, what you need to do is work on an off-screen image, something called a buffered image. It's in memory. It's not actually visible to the user. So whereas previously we created one which is off-screen, just a single unit, worked on it and then displayed it. Here we're trying to be much more processor efficient. Drawing the clock face takes a lot more effort than drawing the hands. So I've created two images. One of them is just the clock face. That's the outer circle with tick marks and numbers. And that's the same size as the physical panel, which is 600 by 600. And then a second one is called off-screen combined, which is where we bring together the clock face and the hands before we eventually move that to the on-screen, to the visible. So again, we get nice smooth graphics. So this is the simple but very important leap, is if you've got something which doesn't change from time to time, create one image for that, then you can download that each time into your combined image with whatever needs to change from step to step. Then you can put that onto the screen. So with that, it's much easier to now describe what we're up to. Draw clock face is the once called image. There's a little bit of mucking around here. We use this, which refers to the size of the J frame. This means the class I'm in. So we're just making sure it doesn't change, and we set it to the middle of the screen, etc. We've seen all these things for basic stroke 2, so we're using 2 pixel wide pens. We've set the anti-aliasing key to be anti-alias on to make it smooth looking as possible. A new piece we haven't previously introduced here is the fonts. So I've used my font 1 and my font 2, both Arial. One is 24 points and one is 14 points. So it's just because I'm drawing numbers and things on the screen, I want to be able to set the style of those. So to create the clock face, I'm always working on graphical structure O. And O, if you recall, just go back there, is looking at, there's O, graphics 2D O, is looking at off-screen clock face. It gets the graphics from that. So this is creating this one-off image that we can then reuse, rather than having to draw it every time slice. So we create a background color black, foreground color white, 2 pixel wide. We draw the oval, which is the circle of the clock face itself. Then we have a number of different radii that we define for the length of each of the tick marks. Then we've got the maths. And if you recall, those who perhaps jumped here before seeing the other videos, there's some useful information about some very basic trigonometry that is essential for this type of work. You need to know how Pythagoras works. These things will probably make your palms start sweating thinking of maths exams from years ago. Pythagoras is important, and also how basic sines and cos work, because this is how we translate screens, that could well be the clock hand, for example, into X and Y positions, because the screen, of course, only works on a grid pattern. So that's available to download with the other programs. So we're using the maths here at the different radii to work out the ends of the strokes that we put across the clock face itself. So this is drawing tick lines, 12 of them for hours and 60 of them for 60 of them here for minutes and seconds, and then we've got a bit of jiggery-pokery here to get the numbers in the correct size and format, because of course if you get beyond 9, 10, 11, 12 or 2 characters wide, it needs to be spaced differently. So it's a little bit of mucking around just to get it looking right. And I add my company name at the bottom, and that's it. But you can see that this is fairly compute intensive. So 60 times we're going through and doing sines and coses here in order to be able to, we could do it slightly more efficiently actually, but all the same we're doing it, it's still compute intensive to draw all these lines on this. So doing it once is a very good idea. Most computers would be able to do it every time slice, but they wouldn't be able to do much else. So that's it, we've drawn onto, using graphics construct O, we've drawn onto the off-screen clock face, which is a buffer image. So going back to our timer, we draw that once, we then call update time every clock tick. So here's the update time. And something new here we've not previously introduced, we're using the construct for calendar. That requires the library appear util calendar. And from that we can extract year, month, day, hour, minute, second, millisecond, etc. We're using a number of different pen sizes here, or stroke sizes, 2, 4 and 6. We make the hour 6 wide, so then the minutes is 4 wide. You can see the hour underneath the minute, and then the second, you can see the minute underneath the second, etc. Here I'm trying to make certain that we get some what we call anti-aliasing. So when we're drawing a second-hand position, I add to it the milliseconds, and I've introduced this before. We use math round, and the reason we do this is that if this was 48.6 6 seconds, or 600 milliseconds, then if we just used int, it would come out as 48, whereas the nearest number is 49. If we use round, it comes out as 49. So it just helps keep things going smoothly in the right direction. Previously we've seen this. We set the rendering hints aliasing to be on. We're now drawing on construct C. Construct C, graphical construct C, points to the off-screen combined, a second buffer image. This is the really key step here. So the first thing that we do is clear the rectangle for anything that was on there previously. So we just take everything off it. This is the crucial step. We then say we lay down the background image. So we draw on it the off-screen clock face, and we used graphical construct O to write onto off-screen clock face. So that's already got this image on it, which can be reused, which is our clock face, all the bits that don't change. This is a really important step once you get to a much more compute-intensive program like the scroll. So you don't want to waste your time recalculating complex mathematics of the shapes of object each time when they're not changing from time slice to time slice. Okay, I then put in the date string using a particular font, and I've used 18 points for that. I then calculate a few things just to be able to position the hands correctly. I'm not going to go into this in detail, but we then basically just draw lines. And again, we have to use the sines and cos to work out the x and y position, to draw lines for the hour first in blue, minute in yellow, and then second in red hand positions. These are the actual positions. They don't just tick along at 1 minute intervals, for example. However, we're only calling these maths sine and cos once for each hand. Whereas if we had to draw the clock face, you recall you've got to call it 12 times for the hour ticks and 60 times for the minute ticks. So it's a lot less compute intensive. So we're drawing still on top of this combined off-screen image. So we can take our time filling that up. We're not seeing this happening on screen. Only when we've completed putting in all of these hands do we then draw it onto the actual screen. So here we go, G, draw image, off-screen combined onto construct G. And G is defined at the top here as pointing out the actual clock panel. So clock panel is the instance of JPanel that you can see. So that's it. It's no different really to what we did in Animate, except that we're laying down a background. We could have done that in Animate, for example, by any bit of the basic construction that drew the girl in the red dress that didn't change, could have been put down as a background and reused each time. So we could have been more efficient if we wished. But once you start to get to more complex programs, that becomes essential. Or essential if you don't want to waste all your processor time. Last bit was just a nice bit of cleaning up here, dispose of that graphical image. We don't need it, get rid of it, you don't want to use the memory. That's it. So what we then get, as we've seen, I'll show you one last thing in a moment, is here's the background. It just remains the same all the time. It's laid down first, then the position of these hands is put on. And if you remember, we put on the hour, the minute, and then the second. But the hour is wide, is 6 pixels wide, minute is 4, and second is 2. So that you can see them go past each other as well. And that's it. At the moment, it's doing a very low computational requirement because it's updating it every minute. Every second. Tick, tick, tick. We could, because it's now very compute efficient, without having to have a very large computer, we could actually make it run a lot faster. So the second hand becomes more continuous. I like a ticking second hand though. But here we go. just make a couple of little adjustments here. So that now our second-hand position is in fractions of milliseconds. And hopefully that's all the bits we now need to make this work continuously. There we go. So this is now updating every 1/10 of a second, and you get the illusion of continual operation. And we can do that because we're very compute efficient. We're not having to recompute the position of all those little tick marks every 1/10 of a second. Sorry, 1/10 of a second. Sorry, 100th of a second, 10 milliseconds. Okay, that's it. This program and all the others can be downloaded from the website, the details of which are given here. So it's www.redford-tech.co.uk/examples.html. You need to get the correct lowercase here or you won't find it. You can write to me, email at simon@redford-tech.co.uk. I've also, I'm about to add the notes about time slices and basic trig, etc. Those will be there, and I will populate it with the .NET versions, VB.NET versions of these programs as well, as they actually were done first. This was about learning how to use Java. I think that's everything for this particular video, and the next one will go into the details of the scroll itself. So it's the fourth and biggest or most complex part of the whole lot. So look forward to seeing you then. Thanks. Bye-bye.